So I'm going to continue to implement the file explorer. Like there's a lot of stuff that I'm thinking about, so I'm going to try to implement stuff right away to get some stuff out of my mind. But I'm probably gonna have to spend a bunch of time thinking at every step of the way. I'm just gonna wait to see if it's streaming. I'm gonna show the stuff that I have on this on Draw first, and I'm gonna show the. Let me just show this right now. So this is basically the list of the steps that I have here. So like I realized that I was thinking about like how I was gonna implement the data on the backend on the model, and then I realized that it makes more sense because I was thinking about as I scan the new directory, if there are events on the front end, I'm gonna have to change the behavior of what is happening, but that doesn't make sense because I, there's no way to react to events in the middle of the function, I think. There might be based on signals, but I think it's not very good. So the obvious answer is to just put on different functions. And because I thought about this, I thought that it makes more sense to create another data structure. So like you have two data structures. One is the faster one that keeps track of what's showed on the view. And the other one would be the model that has a lot more data. And is going to make things faster. So it works as a cache. And then because of this, I was thinking about how I was gonna implement this stuff on the model, but then I realized that it probably makes more sense to create another class. The thing that I'm still not 100% sure is that like this other class is gonna have to interact with the data access as well. So, but I do think it makes sense, like because the question that it raises is whether or not you need the model then, if you need. But I think that it makes sense to have the other class because it's just different purposes. So even though the visible queue is gonna work in a very similar way that the model works, and they're gonna be synchronized through the presenter, through the root path. The visible queue class is going to be a class that manages I'm going to create a queue of paths, and the order of the queue is going to be the order in which the paths are supposed to be shown. And this part I'm not 100% sure, but I think I need another data structure to keep track of the levels of the folders and the files. So I'm not really sure if it makes sense to create a hash map for each place on the queue. So this is kind of the stuff that I'm going to have to think about now. But like I was saying, I think it's probably better to just put a bunch of stuff on code, and then think as I go. But basically, the visible queue is going to be the class that is faster, and it's going to keep track of a range of elements to show on the visualization, on the GUI elements. And then the model is going to work more as a LRU cache. So I was thinking about changing from the model directory, the FS model directory class, to work as an LRU cache, but I'm not 100% sure about this either, like how I'm going to implement the cache. It has to be like it has to be a tree, I think. So maybe I'll still use the model directory, but the thing that I'm not sure about the model directory is about the threads and the mutex to prevent. But then like you need a channel of communication between the visible queue and the model. So the visible queue. So I asked GPT about this, and he thinks that is better on the presenter, and also think that makes more sense to put the visible queue on the presenter, because I was thinking about it works kind of like a funnel, where the part that I was gonna ask now is whether or not it makes sense to have the pointer of the visible queue on the view as well, because that way you don't need to call the presenter. Like the presenter works just to initialize the visible queue and then to use the model. But maybe it makes more sense. Yeah, so I'm gonna ask this now as well. Let me show this stuff first. I didn't do much on the SketchDraw, but just the stuff that I wrote here. So it's basically gonna work like this. And now I'm thinking about whether or not it makes sense to initialize the visible queue on the view as well, and then when I initialize the visible queue inside of the constructor or the presenter, I set the visible queue on the view. And I was thinking that it makes sense because the problem with the part that is very confusing is the front ends. Because I'm gonna probably have to change the 3 and 3 item classes, and the issue is like how do you make sure that the updates are fast? And I think that like the fastest way possible is to use the cache, because then you already have the data. But even then, yeah, this part is the one that I'm not 100% sure how the updates on the queue happen. I need to interact with the queue to remove and add items depending on the events that happen on the view. And just intuitively, I think it makes more sense that the cache would probably be faster because we already have the data. But I'm not really sure if that's the case either. So the problem, also, I'm not really sure if I'm gonna need more. But I think if I need more data, just create another struct inside of the visible queue to to make each item on the list should be of that type. So it's not a big deal, I think. I'm gonna ask. I think it kind of doesn't make sense because the visible queue has to communicate with the model. So I think that it makes more sense to have the presenter. The presenter has an instance of the visible queue and the model, and then it works as the bridge between the two. I think that's the flow that makes more sense. And then as the view interacts with the, but the view needs to have like because the view needs to create. This is kind of the problem. Like the view needs to create the 3 classes, but I think I can do it based on the functions. But it's probably better to have some data structure to pass. And also, I was thinking that I don't need to make everything based on signals, so I'm not bounded by the variant, because the presenter can call the functions directly from the view. So what I need is to, for the state, so I'm going to create a class of the, I'm going to put this on the same spot that maybe I should do another thing here, actually. Maybe that I should do that first, actually. Because it's gonna be easier to organize. So maybe I should create another folder. Probably inside of the GUI elements. Yeah, I'm gonna do this since it's gonna take more classes. It's not confusing later. I'm gonna create another file explorer, and then I'm gonna have to refactor all of the stuff. I think those are the only ones. Delete this cache. I'm gonna compile and then I'm gonna fix the errors. I think it's easier than to search for the imports or the includes. Yeah, I think that's it. So I have the presenter model in the view. So I'm gonna create the class inside of this thing here. And maybe I should probably explain how to create a class on Godot. I made a video about this. It's not that hard once you understand. The hardest part in the beginning always, to understand the overall picture. Once you get it, it becomes a lot easier to understand how it works. I think I'm gonna spend some time like superficially explaining. And probably the video that I made is good. It's kind of hard to me as well now because the more you learn, the more you lose touch with how it is to not know this stuff. So it's you kind of start taking things for granted. It's kind of hard for me to know now. How much should I explain to people that are new? Well, basically, the video that I made is this one. I'll try your own modules. On the class, I'm gonna add the class to the own module that I have there. I should just go back. So I think that the key here is the reason why it doesn't make sense because I'm thinking I want to avoid obviously being very slow on reacting to the things. This way that I'm thinking about structuring, I'm 100% sure that it's going to be a lot faster to load everything. It makes a lot more sense. It's like you have a layer that loads very fast, and that's it's going to display everything right away. And then on the background, they have this lower layer, which has more memory. But the problem is on the reaction. So when you interact with the files, it's going to be, my concern is that it's going to be slow every time you interact. And then the obvious answer to this is to like incrementally have increase the cache of. So this is the part that I think the key is going to be on the like flow of information as it's like you display the visible queue on the view first, and then you have a path of communication from the model, from the cache, to the view in the background through a thread. And then you load like additional data on the tree class that is going to go beyond the surface level of what's being shown. But then it makes me think that you should probably have another data structure on the view. That's the thing. Because the way I'm thinking about the queue as like a 2D surface. So the information that I need on the data structure is going to be X, Y directions. And then I'm going to have to, if it doesn't work like this, I'm going to have to change the structure on the tree class. I'm going to have to create other tree classes, I think. But this is the part that is very confusing to think about. Because that's my concern is that if you have only the two-dimensional structure makes a lot of sense to make it faster. Because then you have like a buffer that goes outside of the visible range to prevent from lagging. And the only information you need is the sequence of files that you need. So it's kind of like you're visualizing an array, and then the level of depth, so that you can do some padding between the files. So that's the only thing you need. But the problem is every time you interact, it's going to be slower because it has to communicate with the backend, which is the cache. Because every time you collapse and uncollapse a folder, you have to change the structure of the entire queue. And I think that's the problem. So this is the tricky part, I think, because I think in order to make it the most optimal as possible, I think you initialize everything on the queue, and then on the background, you create the other data structure that has all the information, which would be the actual tree structure, which has all the information that is visible, and then at some moments, based on some heuristic, you swap the true. So instead of using the queue, you use the tree, because the tree is going to be faster to react, I think. But I'm not 100% sure if that's the best way to think about it. So that's kind of my concern. But I think I should just try to do this way first. So I'm gonna comment out everything there. Yeah, I'm gonna comment out on the view everything that uses the file system, and then I'm gonna delete the file system from the thing. And I'm not gonna use the update tree and create tree functions. I'm going to create the visible queue first, then put the visible queue on the other problem is the configuration that I'm gonna have to pass, but I'm gonna put the visible queue first on the presenter, and then I'm gonna focus only on the visible queue and but this is the problem. So I think I'm gonna have to use the tree first. So I have a function on the view that from the visible queue, so like from the presenter, you call the visible queue function. If there isn't a configuration, you just start from the bottom, from the roots folder. So initialize the visible queue with the root folder. Then the visible queue has a function that uses a thread to run a function that is going to load the amount of items you have based on whatever heuristic. So I can put a number. I think it takes around 10 milliseconds per file. That would be 10 files per second. Or actually 100 files per second, because yeah. And this is the thing, I think that's for one level is like it doesn't take that long to load a bunch of stuff. So it can have a lot of room, I think. So you should probably like have a number like 100 and make the max queue value as 100, and then loads everything. Then like the step of the recursion would be based on the heuristics of whether or not you have uncollapsed folders on the cache or what was visible before. So you have like a bottom and the top elements that determine the range of the queue. Then you put additional values beyond that. If it allows you to put additional values. And so I have to see like, yeah, but I want to think about this stuff as I build. I think it's probably better. Because I need to test to see. I think doing this way is probably better, and using the tree in the beginning, so I can test to see what happens when I uncollapse a folder. I'm gonna have to change the. So this is the stuff that I have to figure out. Is because I don't remember. I think I've seen, but I don't remember the functionality to collapse and uncollapse folders. I think it's part of the tree and tree item classes. It's not part of the view. That's the thing. So maybe we should go over with the debugger first. I know there's gonna be on the. So basically, let me explain quickly. There's actually on the documentation they explain well on the how to create. You basically have this modules folder on Godot that is a folder where you're gonna put the modules you create. And the name of the module is going to be, it has to be the same name as, it has to be on the middle of the functions that you use here. So the module has to have this register times file, the config.py, which I think I didn't use, but it's probably for some customizations on the build, and then sc sub. The sc sub is the file that is used to, on the build system, because they use scones, to put the C++ files as part of the build, to create objects from them, and then link them as a library to the main build. So basically, you put this sc sub file, and then you add, here I think but this is probably on the documentation as well, so I think you can use this add source files. The env is the environment class that scones uses to, so based on the state of the class, of the env class on the scones, is going to build the final command to compile everything. Using the whatever compiler it's selected based on the logic of the s construct, which is the file on the top of Godot, basically this one. And then every time that you have an scon script call here, is going to work kind of like as a function that basically runs the sysub, and it's going to parse everything as a Python. So it basically puts, so this is saying that you're going to put all the C++ files on this level into the modules sources, C++ files. I think you can do different stuff if you want to separate the library, but this is the easiest way possible, I think. And then you have these two files here that have this initialize and initialize Brahma modules. These functions are going to run. They are generated on build time by the sc sub files and the sconscript and sconstruct files. And Godot's going to call at some points of this cycle on the register core types, I think, or register core modules or something like that, is going to generate, is going to call the function that was generated on build time, that's going to put these functions for each module if they are enabled on the build, and it's going to run this function. So when it runs this function, you can put depending on which level you put here, it's going to determine whether or not the classes you put here are going to be builds. I think usually you're going to be on the scene level. So yeah, I think this is where you just put this check here. And then this macro is going to register the types you put here on the class DB. And the class DB is the system used by the editor and the serialization system that they have to make the engine aware of the class. So basically that's all you have to do. So the moment you put the class on this thing here, it's going to register on class DB, and you put it inside the function, it's going to run the function as the engine is initializing on the setup main setup function. And then the editor and the engine are going to be aware of the class you have there. It basically uses this to manage all the types that you have. So it's not that hard. Mm. It's because of the assist sub, I think. And these ones are because they are on the same level. This is kind of annoying about the paths. I'm not 100% sure. I think that there's several different ways to put the paths, I think. Well, these paths are always from the roots, and I think it depends on the way you use the build system there to add the files. This is kind of more complicated, I think, more confusing because of C++ and the way that build system is going to work, because this is a black box. I didn't like the documentation on scones very much. It's kind of hard to understand, and I didn't spend. I spent some time trying to understand from the source code how it works, but I didn't spend too much time. Maybe at some points I will spend more time. Sure, but I think on the concept level it's very easy to understand. You probably have the environment class, which is the main class, and then all the logic is gonna build a giant string that they're gonna use probably the sys environment variable, the sys class, sys library from Python to run the actual commands that is gonna use whatever compiler you select based on the logic you have. And is going to manually run, like probably on Linux, for example, would run make and then puts the GUI command of the libraries and the C++ files, and then it's gonna compile everything like that. I think the steps are first you compile the C++ classes, C++ files to get the file object, and then after you have the file objects, you're gonna use the linker to link them. I should wait until it comments stuff out. Maybe I shouldn't comment the stuff out. I should leave the thing like this because I'm gonna, yeah. So it's gonna be more things to think about. So it's probably better to just leave like this, and then because I'm gonna create the other functions, so it's gonna work separately. So since I don't have, I'm gonna test first to see if it's not gonna create anything. I'm gonna remove from the presenter because the main thing that creates the visualization is the scan, and then the scan calls a function. I think I translated through this last time. So yeah, the model emits the file system changed. So when you run scan, it's gonna run scan new directory eventually, which is gonna update the fs model directory class, which is the class that has the tree basically of the directory. And then after that, it's gonna emit the file system changed on the notification. It's gonna run this callback function, and then this callback function is the one that I'm calling this thing, which this one was directly called before on the view, but now I'm calling from the presenter. And this is the function that is gonna call update tree. And update tree is the one that creates the front end parts based on the model. Uh, so I'm gonna create the new class now. So it'll be fs visible queue. Just gonna copy from this. I have to change this stuff as well. And putting based on the path just to decrease the chances that's gonna be repeated. I think this age is not necessary. I have to put the class on the to register the class. Oh, it should be a node, not an object. For the notification to work, I think. Yeah. This is another thing that's I always forget as well. So maybe, hmm. So it's weird because this was running before. This scan was running, I think. But I forgot to put here, but I have to put stat process equals true. If you don't put this, then it doesn't run the doesn't run the notification function on the notification process part of the cycle. So I have to set it through here too. Yep. So probably was running scan from another part. Or actually doesn't it doesn't yeah, so it was still running because it was on the enter tree and not the notification process. And I'm gonna leave it here. Then I'm gonna comment out. And so now I have to spend time thinking about how I'm going to do this. And so I think that the probably the view it doesn't make sense for the view to have the queue. The view should have a function. View should have functions that are going to create a tree based on the arguments that are passed. Because what the queue is going to be the thing that determines what items are passed. But the problem is that it depends on the way that the tree is going to work. So that's the issue. But I think I should assume that I should use this one first and assume that it doesn't have a cache first and then do things like that. So now let me think about what's going to be the order. So I need to so every time that you don't have the thing on as a child of the like inserted on the tree, you have to delete manually delete. But maybe you should put this inside of the. I think I should add as a child. So I'm probably gonna write down the steps on as comments and then think about like pseudo code first. I was writing down the on SkyDraw here as well. That's the last thing that I was doing here. As I was thinking about. The part that I'm most uncertain is this part about how it's going to work for updating the queue. If it's going to be slow or not. When you collapse and uncollapse. So I think for that reason, I need to have the two different. Like if you have the tree, it's gonna be obviously easier because the tree already has all the data on the. Like it doesn't need to have all the data, but if you have like two extra levels or something like that, like you need to use the shape of the queue and the levels to do the same. Like to have a buffer over what's visible, but it has to be the same shape. So I use the visible queue class is going to be this path here. Like these would be the nodes of the file tree, the folder tree. And this would be the shape that represents what is visible currently. So depending on what folders are collapsed and uncollapsed, is going to change the levels. So I think that what you have to do is use that shape of the curve to optimize not how you update, but how much you load. So you follow the same shape. I think one of the things that makes it hard as well is that it depends on the structure of the directory. So it's always going to be different. It's going to be hard to test as well. Yeah, but I think you should like try to follow the shape and then recurse based on the depth. Like just basically follow the sequence of the paths of the queue, having the level as well, and then recursing or looping over based on the same shape. That makes sense. And the question is how to do this. I think this is going to be on the heuristic of the inside of the argument inside of the function that loads the states. It depends on how slow it is as well. So I mean, as the presenter constructor runs for the first time, the model will create the view queue range first. There's a configuration cache, use the first and last items on the cache to load the state. Build the view queue range based on this. If there isn't a config, just run from the root folder normally. Also run the model will create the view queue range first. If there is a configuration cache, use the first. So I'm gonna write this as a comment, and I'm not gonna do it right now, but and I think I need to put the values on the configuration of the configuration as so I'm probably gonna do this right now. So put as member variables of this class the values that matter the most, which I think is the bottom, top bottom files or paths, top bottom paths. Also need to think about the heuristic of. I think this is one of the parts that makes it confusing. Because not like it's a two-dimensional path, so it's kind of hard to. It depends on where you are on the folder. If it's a large folder, like if you're on the middle of the folder and there's other folders on top, then the room you have outside of the visible range is different. It's kind of like a sliding window thing. So I'm gonna see the configuration here. As on the maybe we should move that first because it's easy. But I think that's gonna change the other stuff, so and then top and bottom I don't have there. Actually. So probably should be should calculate first. Call function from the view to calculate amounts of paths on visible range. So this should be like x, and then visible range should be x plus minus amount. I think you should do everything on separate threads as well. So like the visible queue should have threads. Should add thread, at least one thread. And then I should run the stuff from a thread in the same way that the easiest way is to use a flag variable. I think that is not that bad if you only have one thread and one flag variable. It's easier to understand. The problem is when you have multiple different ones. That's when it gets annoying. But I don't see a way to, unless you have a function. But even if you have a function that's gonna like wrap the other one and then call wait to finish outside of the function. This thing, it doesn't make a lot of sense to me. So like because the examples I saw in videos as well, they don't explain this. Like usually the way that people do it is they like allocate threads on a loop, for example, in the video, and they run a function from the thread, and then outside of the loop they join the threads. But what's is kind of weird to me is that if you it makes sense on a loop because you have more work inside the loop, so you can have multiple different threads working on the same stuff. But the moment you call join, you're gonna block the main thread, I think. So like it wouldn't make sense on my case to run the function on the thread and then just block the main threads outside right away. So that, for that reason, I think it makes a lot more sense to have the flag and then have the block on the notification process. So like you run the notification process only once based on the work you're doing through the threads. But then it forces you to have the flag variable. That's the annoying part. It would be better if there was a way to call wait to finish right after the function is done, the thread's done executing the function. Then you can use the scope threads thing there, but I'm not really sure if that's the best either way. So I think here, obviously, I'm gonna have a list, and I think it's gonna be this. I have to see on the their access. I think yeah, I'm gonna have to. This is the part that was saying that is kind of weird. That I have to use the their access on this class, the visible queue class. So like it's gonna be basically the same thing that this is doing. This one is doing, so it makes you question whether or not you need the other one, but I think it makes sense because of the speed. Like speed and organization of the information, the flow of information. I think that should be a string because the paths are strings. Yeah, so it's gonna be a list of strings. Then the other question is what is the best way to keep track of the levels? Maybe create another struct here and then I put a string in level. Not sure how to call this. I forgot. Should put on top on. I should be. So I'm not really sure why it's not. It's probably because of the name, maybe. I'm gonna ask ChatGPT as well to see what it thinks. So most of the questions that I have are about the like where to put each thing. I think like that's what makes it hard. That like it depends on the circumstance and depends how the thing is going to grow. I think that's where the complexity comes from, probably on all of the cases. So it's always going to converge to the middle of the range, whatever that range is, which depends on the structure of space and time. So it's like the volatility or density of space-time determines the flow of data. The most likely what's going to be the flow of data, which is going to impact the complexity of the code. Because the code is a fraction of how the data moves through space-time. So like whether or not you put the stuff as arguments or parts of the class and stuff like that, it depends on how the overall thing is gonna work together. And it's always very hard to know exactly what is the best approach because for everything's gonna be trade-offs. So that's kind of the difficult thing. You kind of have to set up things in a way that is not hard to change later, but at the same time, like it's most likely to be the correct way to think about it. The simplest way to think about it. So I think here, I'm gonna read this stuff again. So check to see. So in the beginning here, I'm gonna pass without anything, but then the question is whether or not I should always pass as arguments. Probably, I think it probably should do that. Another question would be whether or not you keep the. I think the range is gonna be in index. So you need both the top and the bottom, and then you need the amount of files and folders. This changes the structure of the algorithm. So like the heuristics that determine the path are going to be the ones that are directly correlated with the control flow and the function. And that's going to determine when to do the recursion and when to do the loop. Also here a road to receive. Oh, it's going to be the name of this function. Initialize. I need to write down the question that I have. So I'm gonna think about, then write down the questions, then ask ChatGPT, then think about again. But I'm thinking whether or not. So probably like, so it's gonna do the calculation. The beginning you do the calculation of the view, which is gonna be based on a scroll container or whatever to get the height. Uh, yeah, the height of the element basically, and then divide by the amount of cells, the height of each cell, and then obviously go like round up from that point. Then that should give a number of the range. So maybe we should have the range as I think the range you should probably have. And then it's going to be plus or minus this range to have like the buffer on the line. So I think this is the part that is kind of hard. It's like on the how do you traverse the directory, keeping in mind this range because it depends on the path. That's the problem. Like whatever is going to be shown is going to depend on the structure of the levels and sequence of files. And then you need to start before the top and the bottom, like probably the top because you start from the top first. So I'm thinking about like doing something like breadth first search, where you go through the level, like you use a queue inside of the algorithm, not this queue, but another queue. Then you loop over the root directory. Then when you encounter either an uncollapsed folder, actually when you encounter uncollapsed folders, actually you need to start. This is the part that makes it confusing because you have the top folder, which is the initial one, and then you need a range above that, and the range is going to depend on the circumstance. I think that's the issue, because it depends on whether or not. So, like, let's say, for example, the first visible item is the root. That's a very different situation than if the first visible item is a nested file, like a file on a deep level. Like on this situation here, that's not the root. Then how do you know? Like, how do you go back? So maybe it's on the backtracking, the answer. So like you put the logic of the like range on the backtrack. Does that make sense? But thinking with the backtrack like way is kind of hard. I think that the easiest way is just yeah, you always put items on the queue. You put in, you push. So check first. So I'm gonna think about a name for the function. And yeah, so this was what I was thinking about, is whether or not the function is going to return something, or if I do it based on the. I think it is probably not, so I'm going to do void, because I think I will get from the. I'll get the queue from another function from the presenter, and then I'll translate, or I either pass directly to the view. Then the view receives that. Yeah, but if I want to do like that, then it's probably better to find another way instead of doing this, because like putting the string, I can do two arguments and then put the other one, but then the problem is that's how you link them. It's kind of the issue. So I guess one of the first question would be. This is the first question that I have. So obviously there's several different ways. I think it's probably better to separate them so I can pass as arguments. So like I will change the states of this on the function, of the data structures of this class on the function, and then outside on the presenter. So I'll call first the function that loads the queue initially, then outside of the presenter I just get a get function from the visible queue, and then I use that to call another function on the view that's gonna build the tree from the visible queue. Then obviously I'm gonna have to change the visible queue functionality. And I think I'm gonna try to change, if it doesn't work in the way that I'm thinking, I'm gonna try to change based on the X and Y coordinates. I think I'm gonna try to think like this. So the levels are gonna be the X, how much, yeah, further apart the things are. And the Y is gonna be the range, obviously. And then the only question would be like, how do you update the model as the view changes? I think that's where it gets complicated because you have to translate the path. And this is the part like I know there is something like there's a easy way to do it because you are implementing a functor. So you're translating a two-dimensional path into a three data structure. So like you're translating between types. So there needs to be a functor that changes the shape. The question is like, how do you find the functor? It's like function that receives a two-dimensional path. So the function is going to receive the data structure, whatever data. So I guess this is what it goes like. It's all related because the shape of the functor, the functionality of the way that the functor works is going to depend on the shape of the way you structure the inputs, which is going to be the way you capture the path. Yeah, so you have like a 2D path of visible items. This is one shape. Then you have the tree on the other side. And on the middle of them you have the functor. A functor, as far as I understand, comes from category theory and just a way to say like something, a function, or collections of functions that take objects from one type to another type. So like that's what the way that I'm imagining. Like on the GUI component, you have the 2D shape, which is the path. And then as you scroll up and down, what's happening is that you're translating the shape into a tree, which is the other shape on the back end. And then you need to synchronize between the two as you scroll. But the problem is that I think if you only have the 2D path on the front end, it's probably going to be slower, I think. Because you need to do this transformation. And if you load, in the way that they are doing is like slower at the start because you need to load everything once. But then it becomes faster because the front end has the tree class and the tree class holds the entire state. So like there is no friction on the translation between the two components because they both use the tree. And in this way, I'm changing the shape on the front end, so there's more friction on the information flow between the back end and the front end. And that's the difference. I'll be right back. I think I'm gonna put this stuff in the bottom because usually you don't change this. The way that I'm doing the root path now is based on the button there. So if there isn't any configuration, there's gonna be the button. The button's gonna have the callback function. The callback function is gonna set the path. Then I basically this function here, and I set the path on the model directly. But obviously I don't want to change this now, so I'm just gonna do it like this for now. Just send from this class. But obviously later what I'm gonna do is instead of calling the model, I just emit a signal on the should emit a signal and pass the path, I think. Then I update the path on the presenter, and then I call set root path. And then I update the queue. Yeah, so I'm gonna have to do the same pattern that I was doing on the other one. Instead of calling the constructor, I call here, and then I just do here I was doing based on the configuration. I'll remove the notification process. I was doing based on this, so I'm just gonna move this to the other one. So try to load the configuration. If it does exist, create a button. So on the view, I probably have to do it. So I'm just gonna do this from there, and then I call from the view. So like instead of calling this function to create a button here, I call from the view. Actually, it's probably better to just set the flag variable, and The problem is there's too much things to think about, so I think you should focus on the stuff that's probably gonna be harder, which is the path translationer. Then once I figure that out, I change the rest and try to focus on one thing at a time. I'm just gonna use the rest path. So on the function, I'm gonna have to check to see if there is a root path, and if there isn't, then I just throw an error message, or yeah. Mm. I think I'm just gonna do it like this for now. Think about it. I'm just gonna remove this. The thing I'm not really sure is that, like I said, I think that this data structure determines how the functor is gonna be. And then this is gonna determine how it's going to show updates, like the frequency, or how effective it's gonna be to show updates. So I'm also thinking now that I should probably have two different values here. I should have one value to the bottom, like the starting range, let's say, and the buffer range. It's like the top minus bottom for the amount of elements on the queue, and then plus on the bottom and on the top. Or plus a value that's like double the amounts of room I want to have on both of them. So I'm gonna ask that to ChatGPT as well. But Let's do this first. I think you should do everything based on the values. So I'm gonna have the default values here. Hmm. I think about this. I'm thinking about the situation where, like, so I was thinking whether or not I should pass here, like bottom path or top path, bottom path. And then I was thinking about, like, I have to keep track. So one way would be to create a hash set to keep track of the paths, the visited paths. I'm thinking, like, from the root directory, I start traversing on the load data function, and I use the access to loop over. Then I can either check to see if the path is the top path or the bottom path. I think either way I would like put items on the queue up until the range. So I need to check based on the range. I need to check the size of the queue up until the range. The problem is like what, but I think if I forget to pass, I shouldn't forget because I'm gonna put the logic on the presenter. I think I can assume that I'm always gonna have the bottom path. If you don't have it initially, you just do it based on the. So maybe I receive as an argument, and then if I don't have it, I just go based on the range. So it just puts enough items on the list for the range, and then return. Mm. I think on the front end, I'm thinking about it in the wrong way. The tricky parts is when you already have like a configuration and it loads on the middle. That's when there is a problem. Because then like you can't, you have to build. So maybe you're just gonna be restructuring the tree from the beginning. So as you scroll, you have to restructure based on the traversal of the path. I should focus on on the simplest case, I think, when there isn't like a cache or configuration, then it's just like the front end is just gonna be a normal tree, and then the only thing that changes is the queue is like on the back end on the presenter. So you use the queue to build the initial state of the tree, and then the only difference is that when you uncollapse the folder, you're gonna add items to that folder. Hmm. The problem with this is that it would be slow. Like the more paths you open, the slower it's gonna be. That's the issue. Is it like you kind of have to remove and add things to a certain range to keep things fast. And then this changes the tree structure. Now is kind of the hard part because I have to like I'm thinking about a lot of stuff. I think that like this is the hardest part. This algorithm here, the translation between the because I have to think about the other class as well and like how this is going to work on the algorithm. Because whatever it puts inside of the algorithm is going to be a reflection of how the other classes are going to update. So both on the view and on the model. I think I should always assume that I'm going to have the bottom path. So maybe I should just check to see if the bottom path is empty. Because this is the first question: is the top and bottom path the only thing that I need on this, or should I make them? I do think I need them, but I'm not really sure if I should make them as a member variable of this visible queue, or if I should receive as an argument and then because I'm gonna have to, but the range I'm probably gonna set from the calculation from the view. So like from the presenter, I call a function from the view that gets the range. Then I set that range on the queue from the presenter. So I'm gonna have the range from the view, but I do need the paths as well. But I think I should pass as an argument. I'm just gonna make it as an argument, and the question is, do I need more stuff? So I'm already gonna have the root path here. Maybe we should check to see if it exists first. Like there's a bunch of different questions. I'm not really sure if I should create another function, then the other function is going to be the recursive one. Like this is the hardest part, I think, by far, of this. The thing that is most confusing is about the updates that I'm not really sure about. Like it's kind of hard to think because the hardest part is to think about like backwards. Like from outside of the visible range, you have to think about what's gonna happen. Like if you're showing files or folders that are at a deep level, and then you scroll, you have to like it just feels that it's gonna be very slow if I have to reconstruct the queue each time. But if I have the tree data structure, then it's not fast because it is fast, but it's not. It takes too much memory because then every time that you like it defeats the purpose if it's a very large directory of having the virtual scrolling thing. It's like I need both the virtual scrolling, so like I can't keep all the data of the what's not visible. There needs to be limited to a range. But as you scroll, it has to. I think that, like it goes like the fundamental thing is like the path, which is the structure of open folders that determines like the tree structure. So it's like there's two different structures here. Like the queue and the hash map determine the travel path. But then as you change that path, how do you make sure that the updates are as fast as possible? 'Cause you have to change I have to change the data structure on the view. That's the problem. And on the view, I'm gonna have to like this is the question. Should I construct? Because the issue is that I have to think about the other class to do this. That's kind of the problem. Because the way that the other class works now, I think, is based on the tree data structure. But if I do it on the tree data structure, it's kind of bad because it's not easy to update either. But I'm not really sure if I have the like if the data structure on the front end is just the same as this one to like the queue with the levels, and then I use the same thing on the front end. If this is gonna be fast to change. I think obviously like the key to make faster is the cache on the model. Because the model is gonna have the data, but then how do you synchronize both? I think that's the part that is kind of confusing. Because you're gonna have to update either way the queue. So the problem with the queue is that it's very I think is a lot slower to like change the middle. So that's kind of the problem. Like, if you have a folder in the middle of the visualization, and then you collapse the folder, it's gonna take like you're gonna have to restructure the whole queue. That's the issue. And if you have the tree structure, it does right away. So I'm not really sure what is the best way to do this. I think like it should the best way is probably gonna be like a combination of both of these things. You need to figure out how to use the path to update the tree based on the visible range. So like restructure the tree. Yeah, that's the functor that I was talking about. I think I need to figure out the algorithm to translate the path, this data structure into a tree. And this already is gonna have it needs to be on 2 dimensions. So like I need a vector, maybe not a vector, just 2 numbers easier to think about, easier. So like I need a visible range on the height, the surface, and the visible range on the depth, like a cube. And based on these 2 values, I figure out algorithm to. So I figure out the algorithm to transform to the queue into tree. And then I only update the structure. Yeah, but then I think that this is the tricky part. Is how do you know the boundary? It's like in this way that I'm thinking, I think it would be faster because I would load more than what's visible, and I think that's possible because it's a lot of more files you can load, so you can load more depths. You can load more on the depth and on the breadth than it takes to load the initial thing. But this would be the thing that is visible on the front end, so on the view. But the model would load a lot more because you have a lot more time. So this I'm gonna think about later because I don't wanna get overwhelmed. But the way that I'm thinking about the model and the LRU cache is that it's gonna be like a more complete structure of the tree up until a limit. And then if you open the folder, like passing the limit, then it updates the model to based on the LRU cache mechanism, like whatever is used the most is going to be more likely on the cache. But I think that's this. I have to think about. I don't think it makes sense to start writing code because Like it doesn't matter. Like what matters the most is the understand the fundamental principles and how this is going to incentivize me to create the structure of the things that I think once I figure that out, then it becomes easier. That's what matters the most. And I think that the key of this problem is this stuff here. That's what I'm spending the most time thinking about. I don't wanna write the algorithm there because I know I can write like some variations of like just copy some stuff from the like it's not hard to figure out the to traverse the tree, but I think that's gonna cause problems later. That's the issue. I think if I can use the tree and tree item and then just change the way that I update the structure based on what's visible, that's probably the best way to do it. Like I need to think about like kind of like a scope where the range is like a little bit outside of the what's visible on the screen and is the range that I'm gonna use to construct like I'm constructing a partial tree from the I think ChatGPT says pruning is the name of this. Like I'm constructing a subtree from the main tree based on the 2D path, 2D shape. So that's what I have to think about. But then the question, I think what's tricky is figuring out the boundaries. It's like because you don't want to you want to update as least as possible, obviously. Because when you have to update, it takes time, so it's lower. So and this is gonna go into the heuristics of the range you need to have of the subtree. Fuck, that's hard. Hmm. And because if I'm gonna do it this way, then it doesn't make sense to create a queue. I would have this structure already, and then I would use that to create the tree on the front end. Like maybe I don't need the visible queue. I can just use this structure here on the presenter. And the good thing about the visible queue would be the threads. So like it would separate the threads. I think I need to figure out like what is the how do I think about this stuff here? Or maybe I do on the low data initially, like start writing things here to try to clarify my mind. This wouldn't return, it would return a tree. This is kind of the issue. because then like it would make sense to do on the other one. Maybe I'll do this one first, then when it gets time to translate the information that I got from here on the tree, I think I rethink about this. So it might be possible to simplify, I think. Maybe I don't need this class here. I think that the core of the issue, the core of the problem is translating this structure into a tree and then figure out what is the best way to convert back and forth. I think the problem is that I'm not really sure like how would I write the algorithm also. I'm not really sure what like is the best way to think about it. I think what is confusing me as well is that like you need like there's different scenarios. So and I think it doesn't make a lot of sense to think about the simplest one because it doesn't allow me to think about the complexities of the algorithm. The simplest case would be just to loop over and then just see. And put this stuff here. Hmm. Like I think the other one could be simplified as well because it's kind of confusing to understand this one because of the backtrack. So that this one goes into the like last level of the roots, and then when it backtracks, it adds the subdirectories to the current folder. There's some good stuff here. I think usually what's gonna happen is that it's gonna push the class to the subdirectories of the current one. Like on the backtrack, it's going to add the subdirectories to the current folder, and then it's gonna add the files outside of here. It's like once it goes over all the directories, it adds the files here. This will have to be, I think, like hash stats maybe. I'll check on the current path if it is or it isn't. The thing is that on the beginning you're not gonna have the levels. So I think that's one of the things that is confusing me. I have to think about, but this is the gets into the thing that there's two different situations. One is when you have the cache, and the other one is when you don't. So obviously, when you don't is the easiest way possible. You just loop over the surface level, the first level. So it would be just one loop over the directory, which is basically what's happening here. Like they are using they on the other one they use this one to get the all the files and folders of the current level, and then later they loop over and get and go recursively to get the def. So like in the easiest way possible, I think that it's just this loop here, and then I just check inside of the loop. And I don't need this stuff here. I will just put on the queue, the final queue, and then I'll check to see whether or not, like if the limit was hit, then I would just return, basically. So it would be just the queue of the first level, because it wouldn't have any folder and collapse. So it's very easy. But I think obviously the problem becomes when you have collapse. So I think that I should think about the situation where you have a configuration. So when you have the history before, and why is that really hard to think about? So I think that the situation that I have to focus on is the one that you have configuration, and the last state was showing deep paths. And that's the one that is hard to think about. I think it's hard to think about because outside of the visible range, you're gonna have, like, you're visualizing inside of the tree. So I think this is kind of the essence that I'm trying to like think about how to write, but like it's not very clear to me yet. But the way that I'm imagining is like a ball of light, and then you have a tree, and the visible range is like the ball inside of the tree. So as you scroll up and down, you're moving through the tree based on the shape of the navigation, which is the structure of the levels of the folders. So there is both that visualization, and then there is the range outside, which is the range that is going to have the state, the initial state, which is the stuff that you load. And I think I need to do that in a tree because then it's going to be easier. It's going to be faster to react to events. And then what happens? I think that the problem is that when you react to events, it changes the shape of the visible tree. But then the question would be, does that change the structure? Like, do you have to remove the items? I think I need to spend more time. Before I do this, I need to spend more time studying the tree and tree item classes. Because without understanding very well how they work now, because obviously it would be easier if I could make it work with the class that already exists. So I think I need to, because I'm not 100% sure what happens when you collapse and uncollapse now. And I think that both of these things are going to change. So like the shape of the tree changes when you collapse and uncollapse, and also the navigation is going to change. Delete this stuff. I think that this is the thing is like I don't need to. I can use the tree there. If there isn't a cache, you can just loop and then use the same tree, and it doesn't matter because like it's only gonna have the deep levels if you recurse on the backend, and then you pass those paths as well. But the question is like, how would you update the paths as you traverse? Hmm. These are the other problems that like if the last visible was was a deep path on the inside of the tree, then it doesn't make sense to like recurse because then it's the same problem. Like we're just searching the. That's why I think this was a problem that I was thinking about. Like I can't just push and pop from the queue because then the initial traversal is gonna be very slow. It's gonna be like if you have the previous state, the top path was a very deep folder inside of a large directory, I would have to traverse the entire directory anyway. But if I start from that point, like instead of using the root path, I use the top path as the starting point to create the tree. Then how do I go back to recreate the range outside? That's the problem. I think it's finding the path on the tree. I think as long as I have the like maybe I can go back to the like I can start the search based on the top path. I start the search on the top path. Then reconstruct from that point based on the root path. So you should check to see if they are the same. I'll be right back. It's just very hard to think about. I'm not really sure if I'm gonna be able to do this right now. You should draw some stuff here, see if it helps. I think I have to clarify both the axis navigation and the way that the tree works. But I'm not really sure if that's necessary. Maybe I should do that and just like step over now. It's probably not that hard, I think. Like you just change there and then you pass the path to make this go to the current path. And then you get the next path on the same level using the get next. So like this iterates, I think that each element, each time like this would have the dir axis has the state of the current level. So when you use this is you're iterating over the level of the items regardless of whether they are a folder or a file. And then you differentiate based on there's a function to differentiate. Yeah, I think this was one dot, and then I put two because I want to include the files with a dot. But these two dots, I'm not really sure what it means. I'm not sure if it's keeping the relative paths to go up the directory, maybe. It should be just the name of the file or folder. I think is I think I'm almost there on trying to no like I'm almost being able to clarify like what is the on my head on the shape like that I have on my mind of what's happening. But I don't think it's kind of hard to know what am I missing here. I think the hardest part is the backtrack part. It's like thinking about it from inside of the tree to upside and then how that's gonna change when you scroll. I think it's hard because it's two different domains that are changing in different ways. That's kind of the thing that makes it hard, I think. Because when I think about the tree like this, is different than thinking about on the file explorer, even though it's the same thing. It's because the shape of this that is created by the data structure that I'm gonna have there is like the shape of the navigation changes the structure of the tree you need to have. But the issue is on the cache. Like, yeah, I think that the question is what should be the data structure that holds the information. Because I think it's probably not gonna be good to have the queue because you have to update each time. I guess I think regardless of which way you do it, you need to have the roots. That's kind of the problem. I think that's the reason why I was thinking about the levels, because you need to know how far apart the top folder that's being shown is from the root. But I think I can always assume that I'm gonna have the level. Hmm. So I'm gonna ask ChatGPT if it thinks that the queue is gonna be fast enough to update. I think probably not. I think it's probably not very good. Especially when you have something on the middle and you wanna collapse. Because you have to change all the items. In order to change all the items, I think that if I use the model as a cache, I would search for the path on the folder that was collapsed, then remove the children from the. Actually, from the model, it wouldn't matter. This is two different things. That's another thing. Like there is the data structure that is used in the beginning to load, and then there is the cache, which is used later to update on the background, I think. Kind of like the analogy that I'm thinking about is kind of like maybe like flying through a city, let's say. Yeah, flying through a city is probably the best way to think about it. Like the people on the plane, they're seeing they don't see the peaks like they see the peaks and valleys on the contrast, but the rate of change is different. Like when you collapse the folder would be like changing the actual uh like plane that the people on like the actual terrain that the people on the plane see. So these are I think like there's both the terrain that like is the actual structure that you're visualizing, and then how that's gonna change the view for the plane. I'm gonna step over the tree class. And so they use a scroll inside of the tree class. And so I think I don't need to put the scroll. I need to understand the create item to see what is happening. I think this already implements the thing. Yeah, but it still I still have the problem there. I don't know why I didn't think about this. Oh, but it's still the same issue. But this is an option that you just put like just make it not visible. Yeah, but I think it's still the same issue. Because the problem is the amount of items you have in the beginning. I think that the problem is only on the initial load. I think that is it doesn't matter that much after the initial load. And the matter what matters the most is on the initial load. It's like after the initial loads, you have a lot more time to like load the other items, and I think that is not a big issue. I obviously have like even in very large directories, like it's very likely that the two subsequent paths are going to be very big. But I think it's still an issue here because you still need to have the items, and they're still gonna change. Like I have a situation where I have a bunch of folders in the same level. It's still gonna lag a lot, or it's still gonna take a lot of time to load. So, but I think that's maybe it's more like a replacement of nodes. So maybe I don't need to change the class, because the logic has to be outside. Because I think that the challenge is more about like updating the tree in a way that makes sense based on the navigation path. That's the problem. And so it's like translating back and forth between navigation and the tree structure. So how to reconstruct the tree? I think the issue is that if you reconstruct all the time, then is low. But if you keep everything, then is also is low. Maybe like a better way to think about it is like you have multiple different tree states, and then you are navigating through the tree states based on the navigation path. And this also makes me think that's like I'm gonna have to keep track anyway. But I guess like keeping track of the uncollapsed paths is less of a problem. It doesn't matter, like because you can have a lot more paths. But yeah, I think I'm gonna stop streaming now. I have to sit and just think about this. And there is something there that's like I can think about. I think that there is a way to make this a lot simpler and faster at the same time. And it has to do with this, like the core of this issue that I'm trying to clarify now, but it's very hard. It's like how to make sense of the. I think it's also hard because of the circumstances. So like maybe I should like get to the point where I have an example to test things. But this base, like this is the issue. Mm. It's kind of hard to represent as well with this stuff. Because like if drawing a line here is not very good to have a sense of exactly what is going on. But maybe it does. Like let's say that the like these ones are uncollapsed paths, so they are hidden. Like this changes the way that you have to. I think that's do you have to reconstruct. The situation that I was thinking that it's confusing is when, like the last time you have a state where you stop the view somewhere in the middle here. And I guess like this is the reason why this kind of visualization is not very good to understand this, because you wouldn't like have this visible. You would like, for example, here you don't have the root folder visible. So this like what's showing here is like a subtree of the overall tree. But the thing is, you need to have a bigger tree as a cache, so that is not slow when you move. I guess the path is determined by the other data structure. I think that this is the thing. It's like you have the path, which is the cache, which is this data structure is here, I think. It actually is not the visible. So what exactly would be the? I think I'm conflating the uncollapsed paths with the levels here, because the levels come after. The levels have to be created based on the unclassed paths. I guess this is the problem is because you have to traverse from the roots, I think. Um, and maybe if you traverse from the top and bottom folder. And it's really hard to think about how to think like how to construct the three states up to a certain limit based on the path. That's what I need to figure out. How to construct based on the path. I think you should think about I need to create an example first, but I think I should think about in terms of the top and the bottom paths. 'Cause this like I need to think about the range from these points first. So there's both this and then the uncollapsed paths, and then the uncollapsed paths can go outside of the scope of this. So like I think on the function it would be better to start from the top path. and then you reconstruct the state up until the top, the root folder outside based on this. So I have to traverse backwards. And then from that point, yeah, I think that's probably. So let me think about how to create an example, like a simple example. The problem is that I need to pass the configuration there. I think that's the issue. This is kind of the annoying thing because then I need to change everything. Because the way that it's working is based on the on class paths here, which is gonna be saved on the other one. And then like you have to interact with the thing. I have to load first, interact, then save the unclass paths. So I'm just gonna write here. I think I'm not really sure if I'm going to need this if I figure out. How would this look like? So I start from the top. So it would be the same thing as this one, or just loop over the current directory. And I'll have to change to the. And maybe I'll have to create another function to do this outside. Should probably create another function and then call this one from a thread. And I'm just gonna do it like this for now so I can think about it. So I would probably pass here as well, our current level. And then increase by 1 each time. And I wouldn't have this stuff here. I want to change this later, but I'm just gonna leave it like this for now. But let me think. So here I would call the function recursive to the. So if uh, so I have to ask how to check to see if it's on the hash sets. Yeah, I think that's as long as I should probably do it like this, and then as long as I figure out how to translate the path into the new items, I never delete items. So I start with the tree, then I use the queue to update the tree based on the levels. That's probably what I should do. So I should figure out how to. The question is, I think that what makes it confusing is the recursion and the backtracking, because you have to think about from the like starting from a lower level. How do you think? How do you think about the recursion? So I think that you have to check based on the level, and then you have to call the function recursively. But if you call recursively, unless you pass the parent as the yeah, if you pass the parent as the argument, then it works. So do the heuristic based on the current level. So compare the current level with the level of the current path. Then based on this, you call recursively, passing either the parent or the child to traverse back and forth. And then instead of removing the elements from the tree and reshaping the tree, you always increase. But then that's the issue, is because like once you hit a limit, it becomes very slow. But maybe it doesn't. I think I should start. I should try to start off like this, and then check to see if it works. Then I think about whether or not it's necessary to have this limit, to remove elements of the tree in case it hits the limit, and then try the other elements. I think it's just hard to think about because of the recursion. It's not very used to. I think it's just unintuitive to think about recursion when it comes to backtracking as well. Makes it very hard to think about it. So it just has coordinate to GPT, no tasks. And here we would call the function recursively. And here we would check for the. This is the thing, is like how. Hmm. I think you just update the top path each time. Or maybe it just puts another one to make it easier to think about. I think that should probably put another one. I think the bottom path is not. I don't need the bottom path, because what matters is the range, not the bottom path. So once I calculate the range from the view, all that I need is the path on the top, and then I just use the limit of the range to know the queue size. I think I need to check for the queue. So I'm gonna change this so I pass. I'm gonna create another function. Maybe just put the same name and just put the other one with an underscore in the beginning, because I'm probably gonna call that from a thread as well. So I think I'm gonna follow a similar pattern from the model. That it calls this from a thread. Let me think of this. I think the list is size. So it'll be. think I should check here as well. Visible size. Not sure. Probably buffer is not a very good name, so I'm gonna think about a different name as well. Then should return, but the thing is, I'm not pretty sure about the backtracking. I think if I do it like this, it doesn't matter because like it's not gonna go from that point. I think it would continue. No, but you would just return each time. No, but then yeah, there's a chance that you would add more on the same iteration. So I need to put the check here as well, probably. If I do it like this, it's probably smaller. And the problem here is that I'm not gonna I have to change, I think. I think that this call here is gonna change to the folder. It changes the path on this one, which makes it go deeper on the recursion. And I think this to avoid an infinite loop, so I probably should put there as well. Just checking to see if the current path is equal to the changed. If the current directory is equal to the changed. And then it's passing this as the argument as well. Like the thing is like here it doesn't really solve what I was thinking about. Like I still have the same problem there that I'm thinking. Because the visible range has to be based on the yeah like oh maybe I don't do it based on the buffer then. Like I just do it based on the I do the buffer outside of the function. But then so I think I might need two functions maybe. Because I need one to go outside of the scope of what's visible, and it has to be based on the levels, I think. Like from the top, it has to find the function that goes to the parent using the access until it gets to the roots, but then I go one at a time. I would have to, so maybe I would loop on the reverse order from that point. But it makes me think that there's probably an easier way to do this. It's probably with to do with backtracking. I think on the backtrack I should do something like this. But then it would be, so I think I need to start from the top path so that is faster. So the base case, the top path is going to be the roots directory. I need to start from the top path, then builds like, so starts from top. The thing is that I'm not really sure if it's better in the beginning to try to build backwards your roots based on collapse folders. If there isn't anything on the uncollapsed folders, then it's just a reverse. Just looping, like go back one directory using the dir access, and then loop over, and on the reverse order. Then you should see if that's possible. I need to see if there is an algorithm for this already, or if I should just do it. And maybe I'll divide the range by 2, the limits. So I'm gonna have a fixed limit of files. Maybe just separate to make it easier, separate between upper bound and lower bound. I think it's just easier to get the limits divided by 2. I think you should traverse first. I think it's easier to traverse first. So maybe traverse from the top. And it's probably better to do this outside of the function. It's probably better on the recursion to make it as easy as possible. Just to assume the roots. So I think that the part that is confusing me is this about starting on a point that is deeper on the tree and then going back. So maybe we should do this outside. But either way, I think you need to navigate from the. So I think I should break down into two different functions. So like one function navigates. Yeah, but then does it matter? It doesn't matter actually. It matters. So the only thing that matters is that because you're not gonna get the roots on all cases. Whether or not you get the root path depends on the unclass paths and the limits. It should navigate from the top path to whatever path it hits, either roots or unclass paths and limits. Sure. Yeah, so I just go from the top path to the roots based on the limits divided by 2. So that should be the visible range plus whatever amount I want outside of the visible range. Maybe the uncollapsed paths don't matter for this. It matters for the recursion, but because the function would be, I'm gonna create another function. Should think about this. I think I need to know the level of the top path. Should probably pass the current level as well. And then I count, and then I save for the other function. So like start. No, I would start from whatever folder I get on this one. So I think this one has to return a path. And then I would use this path to call this other one from another function. So I first call this one. So maybe I should have to, like I should have an overall function that is gonna run inside of the thread that is gonna call this true. So it's gonna pass the path that should probably puts like current path. I think I'm just gonna copy the scanner directory for this function here. I'm just gonna copy this and then change this to a path instead of this model directory. So I think at the beginning I'm not gonna I'm gonna create the current levels based on this. The beginning I need the uncollapse. I'm not sure if that's the best way to write this. I'll think about this later. Once. So in the first part here, I just need the uncollapsed paths to check the uncollapsed paths. So now, how to go back from the top path to roots and stop on the limits range. I'll be right back. So obviously this depends on the way that the axis works. There's a lot of questions about the nuances. That's kind of the problem. Because like if I want to go back, I need to like I could get the values on the current level, But then, like, what does it mean to do them on the reverse order? It's gonna depend on the way you compare. It's gonna depend on the way you organize. So in the other one, it uses the function from the list to organize the order. Like I could make this as parts of a member variable and maybe make like an enum or something like that to determine how to structure this, because then obviously you need to make sure that I go on the other order. But I'm not really sure if I like this because it just increases the chances of making a mistake or making it harder to debug. It seems that there must be an easier solution than this. But you can't really start from the root because you're not sure if you're gonna hit the limit until like in most like it would defeat the points if that was always the case. So this only matters for situations where the limit doesn't reach the root from the top path being shown. Let me see what GPT says about this. I think I would just have to figure out how to go up based on their axis. I could do the other way, but it's kind of bad. It goes into the thing about the relying on the order, which is kind of bad. Like here, it sorts everything based on this. So obviously, I could go over like this and then sort the other way, or actually not. I would need to sort and then go back from the end of this. Like add the items from the last item and not the beginning. So basically loop from the back here. And then decrease the index. But it's not very good because I don't want to rely on this case comparator here. Maybe that's the only way though, because that's how it's working. Yeah, I think that this might be the way, actually. So like I would just do the same thing as this is doing, but on the reverse order. I think that's probably the right way to do it. Because this one is already relying on this anyway. And then on the recursion, instead of changing to the current path, I have to figure out how to go back one level. So maybe I should first check to see if that's possible. Yeah, the problem is that if I move up, I have to stop. So maybe I should check to see. I should check to see inside of the loop if it is the current path. So like the same check that they do here to avoid the recursion, I do inside of here. Because like when I go back from the first level, on the higher level, obviously I'm gonna encounter the top path again. So I need to stop adding items to the list at that point, I think. Or maybe here I can go to the ends. So maybe there is a. I think I have to go over with the debugger to see because it depends on the operational system. But I want to see on the implementation because there's probably another function to get the ends, but then I'm not really sure if it would loop backwards. It's probably not gonna compile. I'm gonna have to change. Because I'm thinking like if I can loop backwards here is better because then I can add right away to the queue. Yeah, I think that I need to figure out this way. And then I can recurse inside of the queue. I don't need to do this stuff here. And so I think that's what I have to do. If I could do the same loop that they are doing, but then the problem is like if I can loop backwards, then I think it's more annoying because I have to do this other stuff. But maybe I need to do this anyway because of the sort here. Yeah, but this is not very good. I need to find a way to do inside of the first loop, I think. Because then, like, if there's a bunch of files, it's gonna defeat the purpose because it's gonna hit the limits. But actually not if I put the risk like in the middle of the loop. I'm probably gonna have to create another argument and then like to keep track of the counts because I can't initialize to zero here each time. As it has to accumulate on all. It's like if I can't put to the on the queue here on this loop, if I could put on the queue, then I can just check based on the queue size to see if it's the limits of files and folders. Yeah, not the overall limit, but just the range outside of the visible range. I think I'm gonna stop streaming now because I'm already tired. So I'm gonna think about this off stream. But I'm probably like the thing is I'm not really sure if this is not gonna be necessary. I think that like the main thing that is confusing and I feel like there is something but I can't quite think about it right now is this translation between the 2D traversal of the tree and the reconstruction of the tree based on the updates. That's the thing that is tripping me out. It's like how to associate the 2D navigation there that depends on the structures, like these two structures and then collapse paths. How to associate this with the tree state. I think that's the essential thing. And directly this is going to be directly reflected on the algorithm. And that's basically what it's doing there. But it's very hard to think about. So I'm probably gonna spend time like getting to compile first here, and then maybe going back to the like calling scan again from the presenter. So I can step into this and to see if there's other functions. Maybe I could go to the base class to see. Yeah, but then to see the actual implementation, you should find the ones that are going to depend on what operational system you're using, I think. Also, the ends just clears and the beginning pushes. I'm gonna try to think about like like the best way possible to translate this to the path into the states of the tree, and then how to connect the algorithms that are gonna pass the data back and forth. And the reason why I'm not really sure if I need this queue is because I can do like initially I have the data structures that have the cache, which contains this 2D path from with the levels and the paths of the previous state, the last state. And then I can use that only initially to load the first state of the tree. But then as you scroll up and down, it's or both as you scroll and like on the background, the model updates the state of the tree on the view. And I think if the algorithm on the front end is probably going to be just very similar to the one on the visible queue or on the presenter. Because it's more about like figuring out how to translate the navigation into the tree state, the visible tree state. Yeah, but I need to spend more time thinking about like this, thinking about the recursion and the limits of like, I have to clarify, spend more time clarifying exactly what I can do with the data access first. Like once it's very clear what I can, like the way that I can navigate, I think that's one of the things that is making it harder because I'm not 100% sure. So once it's very clear the limits, then it's gonna be easier to think about. And the thing that's I also don't know for sure now is whether or not this is the correct, like it seems kind of off. That's kind of the problem. Like it seems to me that there should be an easier way to like this traversal backwards from the top, the visible one, the top path visible to the either the root or the limits. It doesn't seem that is the correct approach, the correct way to think about this. Which makes me think that there's probably an easier way. Like either is not the correct approach or it is the correct approach, but I can do everything on the same algorithm because it's the same pattern. It's like translating the shape, translating the 2D shape into the tree with the functor. It's basically this is the essence, I think. And then thinking about whether or not I need to have this class or because the other component of this is the tree and tree item classes. And it's kind of, I'm not 100% sure on how it works there. Like just based on what I've seen there, it looks like it's gonna hide the items that are not visible, but I think that it still matters on like they are still part of the states of the tree. And I think I should figure out, based on this should the path thing, you should remove and add nodes from the tree. So like as you're scrolling up and down, you're creating different trees based on the navigation, which is the cache. But then like how to connect both things, I think is the part that is very complicated. And I need to clarify more the classes that I can use before, like both the D-axis and the tree class. As it seems here that it's just gonna keep track of the size of the cells and then do the calculation on the draw here. Yeah, I'm gonna stop streaming here. I'm gonna think more about this. The problem next time I'm gonna continue to do this. I think I'm gonna spend most of the time trying to figure this out here, I think. Once I like it's kind of I'm almost there, I think. Like figuring out trying to figure out this, like almost able to figure out, but I'm not quite there, and I think it's not worth it to just write the code because it's kind of pointless. It's what matters the more is the fundamental thing. And what makes it harder is the nuances of the cache and the state and stuff like that. I think that's the part that is. So I need to like take a break and then like clear my mind and think about like from a fresh perspective on how to do this. I need to clarify exactly what like there is something that I can't quite put the into words that is kind of making me like the I think that is the core of the issue. And it's kind of hard to put into words because I don't fully know yet what it is. But I know that there is something there, like, but I don't know exactly how to like put it in my mind. Is it something to do with this navigation of the path in 2D? I think it's like the cache state navigation path and then the construction of the tree based on the path. I'm gonna stop here. I'm gonna think more about this. Probably next time I'm gonna continue to try to figure this out. So see you then.